Hi, my name is Tim Lindquist. I'm a professor in the software engineering program at ASU, and this is a video in support of our course in mobile app development, SER 423. The subject of this video is Android networking and asynchronous activities. It's in support of Unit 6 of the course. What I'd like to do is to go through, actually I'm going to very quickly go through the references for the material for the readings, but more particularly we'll spend some time executing the first three examples or sample programs that are there. There are readings suggested in Murphy's textbook, as well as some online references. Probably the first of those from the Android developer on network operations is very good. It talks about different approaches that the app developer should take in terms of doing networking. It also discusses a framework, a GitHub available framework called Volley that really is very good, but frankly, it's hard enough to support examples in this class when they only depend upon the manufacturer's APIs. Those change often enough that it takes a huge amount of effort to keep them up to date. Try and do a third party. In fact, things just get worse. So we're not going to do any of those. Nevertheless, there's a good reference for them in there, and they are very widely used. The other two references here links are for the class reference for async task. We'll talk about that, and also for handler, and then another web reference that goes through more of a tutorial of how to use them. So the two important things about doing networking in an application are first of all that any networking connection or any network connection or actually any task that takes a reasonable long amount of time should not be done on the UI thread or the main thread. So that's the first principle. If you do a long operation on the UI thread, then it stalls the user interface and the user sits there, what's wrong with my app? So the second principle is that when you're off the UI thread, using some other thread as we do in Android or a background activity, you can't make a change to the user interface components. So the app developer has to deal with those two issues, right? The first one is I can't do long duration tasks on the main thread. So I have to use a secondary or an asynchronous activity. And then when the data that I want to get from the network or whatever comes, I can't in that asynchronous activity go back and change the UI components. So I have to kind of pass the data back and forth in order to allow the views to be updated. Those two principles have affected significantly how you do things on both of the APIs, on both of the platforms, iOS and Android. And in Android, the two approaches, most common approaches, are to use the async task class. You extend it, and we'll take a look at that. And then the other one is to use what's called a handler, and then pass that handler to another thread, let the other thread do the network connection, and then it will post something to the handler, which will cause the user interface to be changed based upon the information that's available. So both of those approaches for Android, async task and the handler with a thread, are demonstrated in the second and third samples here using JSON RPC, and we'll take a look at those. So let's go ahead and actually I've downloaded, I think I've got all three of them here, and those jar files. And let me just explain. So the first one is a JSON RPC server, and you can run it. It generates an executable Java jar file. It should run on either Windows or on Mac. And so you need to bring that server up first before you can execute either of the other two sample Android apps. And it turns out that that same server is used in the next section on networking with iOS to demonstrate how it's done in iOS. So let me show you how to get that server up. You may not do it the way that I do it. If you just double click on it or extract it, download it and extract it, that's fine. But you need to get into the directory that gets created for it. So I've downloaded it, and you can see from a listing of the current directory, student collection JSON RPC server. So extract that. And then change to that directory. You'll see there are some sample shell commands in that directory, and I don't think it comes with it already built. No, it's not. So it actually requires ant, which is available. If you look at the readme.txt file in here, it'll give you a link to ant if you don't already have it on your system. I think it's build.java.server. Yeah. And then after it's built in the live directory, you'll see a student server.jar, which is a JSON RPC server. It communicates with the clients over HTTP, so the clients make an HTTP request to the server. It works just like an HTTP server, but it doesn't know anything other than JSON RPC requests for specific student operations. There's source files in the source directory of this project if you want to take a look at how it's done. But in any event, let's go ahead and run it. I'll show you how to run it using the Java runtime environment. Indicate that it's an executable jar file, java-jar lib, and then student server.java. And then you have to give it a port number. All right, so most HTTP connections are over port 80. This one, it doesn't matter what port you use as long as you change the app so that they know what port it is. By default, they use 8080. So you can start this up in the background if you want to, or you can just start it in the command line, however you choose to do it. You can see that what happened is that it goes out to a JSON file and reads in this case, information on two different students. One of them is Jim Buffett and the other one's Sally Smith. So now if a client connects to it, it's going to see information about those two students. It's as simple as possible server. So let's also take a look at the first approach. Maybe I'll describe it before we do it, but let's just go ahead and extract. We're going to look at the async task first. So bring it up in Android Studio, and let's go back to the async class definition. So the async task is a class that's provided with the Android API, and the idea is that you would extend it in order to make a network connection. And the way the async task works is it has actually I think it's 4 different methods that are available. The most important one is do in background. We'll see how we get all these started up. Do in background is the method in which you would implement your, in our case, HTTP JSON RPC request. And then on progress update is a method that you can optionally implement if you want to override it, and it would provide you with the ability, if it's a long duration operation where you'd like to show your user a progress bar, then this would be the method that you would call periodically from within the do in background to make updates of your progress bar to show that the status of a download, for example. That one's sometimes implemented, sometimes not. And then the third is on post execute. So the do in background is done in the background. You can conceive it being done on a separate thread, meaning it's not the main or the UI thread. So in fact, it won't frees up the user interface when it goes off and waits for a request to be responded on the network. And then on post execute runs back on the UI thread. In fact, that's the case also for on progress update. Both on post execute and on progress update execute on the main or the UI thread, which means that from within the body of those, if you override those methods, that you'll be able to make changes to your text view or your edit text or whatever. You can access the view objects and make changes to those view objects because those methods are run on the UI thread. And that's the interesting thing about the asynchronous task. Now there's also a fourth method. I don't see it here right away, which provides for, it is on pre-execute. So pre-execute gets called before doing background in case there's some initialization things that have to be done. That can also be done as part of the default constructor. So here's a description. So this is actually part of the reference documentation. I think it's pretty straightforward. If you take a look at it, you'll see. The problem with using a sync task is that in the on post execute, depending upon what you've done in on background, you may or may not know exactly what has to be done in on post execute. So oftentimes you'll see apps where there are several classes defined that extend a sync task because there's specific actions that have to be taken, or you'll see very complex code in on post execute that tries to define, well, did I just do a request for to get information about all the things on the server or about a specific thing on the server, or did I just make a change to the state of the server? What actually has to be done to my view based upon what the request was. And you'll see in the example that we do and in the exercises that in fact there's quite a bit of overhead that's involved in generating these extended classes for on post execute. Okay, with that background, let's go ahead and go back. We've got the server running, so maybe the best thing to do is to just go ahead and execute this. And in order to do that, let me bring up the Android emulator. So the idea is in this particular example, or both of these examples, that the model that is going to be displayed in the views only comes from the JSON RPC servers. So there isn't any information within or at least it's minimized anyway, information within the app that has to do with the information that's going to be displayed in the views. There we go. So when the app comes up, it shows the information about one of the students. The only information that's being kept is the name of the student's number. I think there may also be courses that the student is taking, but this app doesn't show those. And in fact, so in the app there is a spinner which lists all of the students that are available, and when you select a different student, then their information is fetched from the JSON RPC server and it's displayed. So you can see I'm switching back and forth. And then since we haven't talked yet about app settings, if you want to change the URL that's used for the connection, so if you use, for example, a different port, or if you had it running on a different machine that was on the network, then in fact you could change this URL, and then by doing refresh it causes it to go back and reload. So let's take a look at the code for this app, and I've got it on the screen now. It consists of 5 different classes. There's the student class, which is, as we've already seen, it's a class that has the student's name and their ID number, and then a vector of the courses that they take. And the ability to convert it to and from JSON. The ability to convert to and from JSON is necessary in order to do the JSON RPC. In other words, if we want to add a student, then we're going to send a JSON RPC message to the server, and that JSON RPC message is going to have a JSON representation of a student. So the student class we've already seen. Method information is a class that's nothing more than a holder for information that's going to the async task to make the connection for us. It actually gets passed from the do in background to the on post execute, so that the on post execute knows not only the results, but it also knows what the actual request was that took place, the main activity, and then these other two classes, async collection connect and JSON RPC request via HTTP. The async collection connect is the extended async task, and that contains our do in background and on post execute. And then this is a helper class, JSON RPC request via HTTP. It's a helper class that constructed in order to do an HTTP request. So the most interesting stuff, well, let's actually start at in the main activity, take a look at how the main activity calls one of the methods, right? So if we go back up to on create, you'll see here's the very first one, the first call. It creates a method information object. So this is the call that is being made in order to get all of the names of students, so those can be used to populate the spinner. So we create a method information object that has the activity that's making the request. It has the information about the URL for the connection, then the method that's being called, and then any of the arguments. So in this case, there aren't any arguments. It will then create an instance of our async task and then ask that instance to execute based upon this method information. Right, so this is kind of the way that the calls are made. Notice that it's within a try-catch block because it can throw. And also notice that it's like although it's not an asynchronous call, what happens is you end up calling or constructing and doing the execute, and the execute will cause the do in background to be started, and it will return to this point before the actual HTTP connection has been completed. Right, so this is maybe the first time many of you have worked with asynchronous calls and threading and asynchronous types of programming. So that's one example. There's a couple of other examples in the main activity that show you other calls to the server, but we're not going to go through all of them. So then within the async extended class, so async collection connect extends async task. As I mentioned before, it's generic. And so the reference documentation shows what each of these different values is for. The first one is the argument that's being passed to the do in background. The second one is if I were using the progress, that would be the type that's being passed to that. And then the last one of these is what's going to the on post request after the connection has been made. So in pre-execute, on pre-execute, I overrode this, did an override on it just so you can log and see that it's called. And what this also, if you look at the logs that get generated by this, they'll tell you which thread the particular method is running on. And I can guarantee you'll find it on a quiz or a test. It'll ask you on pre-execute, does it run on the main thread or does it run on a background thread? Same thing for the other ones as well. So there's this Android log in everyone at the beginning of each of those different methods. Take a look and see which one they run on. So the do in background causes the HTTP request to take place, and then it does a return. Notice that its argument is an array of method information objects. And in our case, we know that it's only being called with a single one, so I without apology, reference 0th element of the array, and then I also return that at the end. So do in background will run in the background. Meanwhile, the main UI thread is going on doing other stuff. When the HTTP request returns, it's going to do in background will return the result inside of this method invocation object. And after that return occurs, onPost execute will be called, and the return value from do in background will be passed as the argument to the onPost execute. So in onPost execute, you can see within a try block, it says, did I just get the names? If so, then there's an adapter that I need to build for the user interface. That's the drop down that has the names of students in it. Otherwise, is it a get? Did I get the information on a specific student? If I did, then in fact I want to go and put in the name edit text and the student ID edit text information based upon that student. And I guess then also as an add, and I think with an add there's no, oh yeah, with the add you need to refresh the drop-down list. So I'll leave you to read that, but that's the post onPost execute. Before we go on and take a quick look at handler and thread, let me say that it's also a common idiom in an async task to only have an interface that's implemented by a delegate callback. And if you want to see what I mean by that, I've included in a later unit, which would be down in preferences. Here it is in Unit 11. There is this is where we show app settings and talk about app settings. For Android, there's a settings JSON RPC student. So this is another example of the exact same app that uses async, but in this case, it actually defines an interface so that the onPost execute only has to call a delegate that's defined in that interface. So it's another very common approach or programming idiom for using an async task instead of having the somewhat convoluted or the nested if then else to decide what was the context from which I made a request, and based upon that, what's the appropriate thing for me to do after the request has been satisfied. What you do is actually call a method on an object that implements the interface where the method is defined, and then it should know, quote unquote, should know based upon the context what needs to be done. Okay, so let's leave it at that for that app, and then let's go back and take a look at the other approach. Maybe I'll describe it first. So this is in the student JSON RPC client via thread. This is using what's called a handler and a thread. And let's go back up to Unit 6. So this is the third example here, student JSON RPC client via thread. And this is using a threading and a handler. And maybe instead of actually going through the details of that, I'll let you go through it. Here's what happens in this case. Android API defines a class called a handler class. And a handler class has this special characteristic that when you create an object of a handler, and then later post a runnable to that handler object, that runner, or the runnable, which is just like a thread, a separate thread, will be executed in the context or within the thread that the handler was created in. So the idea is, in main activity, we create a handler object, and we pass that handler object to a new thread that will run in the background. That thread that runs in the background makes the HTTP request, and then when the request has been satisfied, it uses the handler object that was passed to it and posts on that handler object, which causes the the operations that take place after the HTTP request has been satisfied to be executed back on the main UI thread. So it is another approach that works just as well. It's not my preference personally. The reason is that you end up having to create several different threads or runnables classes in order to get it to work properly. And actually, we'll see in iOS that this whole thing about threading is an outstanding issue with respect to efficient execution of mobile apps. The async task actually has a fairly long history. It actually was added, something similar to it was added to Swing and exists in other APIs as well. Android is not the inventor of the async task, or at least I don't think it was. I think it was actually in Swing before it ended up in Android. But nevertheless, it's fairly well established. The thread and handler is something that's not as prevalent as that approach. All right, so I'm going to leave it at that. The other two, Echo command line server and client, shows or demonstrates how on a separate thread you can do a TCP/IP connection from within an Android application, right? So the HTTP is not the only networking facility that's available. In addition to Volley and the HTTP that's used in the example for my async task and the thread and handler task, there's also the ability to do any other kind of a network connection. The API that Google has provided for Android is very similar in terms of networking to the API that's available and available for on the desktop for doing networking in Java. Okay, so I'm going to leave it at that. I'll let you take a look at those other examples. And in the next video, we'll be talking about doing networking on iOS.